Okay, nerds, so today we're going to tackle section 3.6, and this is going to be the last section before your next test. Like I told you, your test will be later this week. It'll be Thursday. This lesson is about the quadratic formula, which you learned about in Algebra 1 and you used in Algebra 1. But more importantly, what the quadratic formula can do for us other than find solutions. So on the front, we're just going to find solutions. But before I do that, on this next example, bad copy-paste job, if you would please change this 8 to a 2. So it should have said minus 2x, not minus 8x. So sorry. And it'll be back on screen in a minute, don't worry. The quadratic formula on, was it Friday? Our last lesson, I showed you guys where the quadratic formula comes from. The quadratic formula is the result of solving a quadratic that is in standard form using completing the square when there's no numbers. Standard form of a quadratic will be ax squared plus bx plus c. This is standard form because it counts down in order from biggest exponent down to no exponent. Anyway, if you solve this, if you set this equal to 0 and you solve it by completing the square, this was the result. So this is a skeleton key. It'll open every quadratic. The quadratic formula can solve every single quadratic, whether or not your answers are real, irrational, complex. It doesn't matter. This will do it all. That doesn't mean this should be your go-to solution type or method. I hate using the quadratic formula, to be honest with you. I use this as a last-ditch effort. It's the last one I go to. I always try to factor first because that's fast and it's easy. And then if it's not going to factor nicely, I go, okay, well, could I complete the square easy enough? And remember, the way I determine that is if after dividing this number out, if I still have an even term in the middle, then I'll go ahead and complete the square. So like this one, 8 divided by 4 is even. So I would have completed the square on this one because it won't factor. But if you're the kind of person that doesn't like completing the square, then if it's not going to factor, I guess you would go directly to the quadratic formula. Yeah. Again, why don't I use it? Because it's slow. And there's places where you could accidentally goof up your substitutions or mess up your double negatives or, oh, I just did some arithmetic wrong here or I misused my calculator right there. Just things like that can go wrong. It's got a lot of moving parts. Also, you have to have it memorized. You guys know the song? Alexa, you know it? Yeah, you want to sing it for us on the mic? No? You sure? Okay. There's a song? Yes, there's a song. Well, you already know the words. Here's the good news. You already know the lyrics. They're right there. Okay? So you can either sing it to the tune of Row, Row, Row Your Boat or Pop Goes the Weasel. You don't know Pop Goes the Weasel? No. All around the mulberry bush, the monkey chased the weasel. Monkey stops to pull up his socks. Pop goes the weasel. No? Sure. I guess I'll do Pop Goes the Weasel because I just did actual Pop Goes. How do you Pop Goes the Weasel? Anyway, x equals negative b plus or minus square root b squared minus 4ac all over 2a. Pop Goes the Weasel. X equals negative b plus or minus root b squared minus 4ac all over 2a. Row, row, row your boat. Who came up with what? They just saw the formula and they were like, that can go to row, row your boat. I don't know. Cutesy teachers. I'm not one of them. Alrighty, so let's go ahead and solve the quadratic. Let's solve this quadratic using the quadratic formula. Again, I actually would have solved this by completing the square, but let's go ahead and use the quadratic formula since that's what these notes are about. Identify A, B, and C. A will always be the number in front of x squared. B will always be the number in front of x. C will always be the constant. See how constant starts with a C? That means it will not have an x. There it is. I write the quadratic formula every time I'm going to use it. So I try not to keep anything in my memory. Isn't that supposed to be 2? Isn't B supposed to be 2? In the second example, it is. Oh, I think so. No, in the second one. Sorry. negative, and anytime you substitute, please use parentheses. Here's your b term. Here's b again, squared, minus 4 times a times c. There it is. And 2a. Then you just clean it up. Please do not go instantly to a calculator. If you type this on a calculator right here, and you don't use parentheses, it's going to give you a negative result. But you know negative 8 squared is positive. So please don't go instantly to a calculator. Trust your math skills a little bit. Anyway, negative 8 is positive 8 plus or minus square root of negative 8 quantity squared, that's negative 8 times negative 8, is positive 64. And this is negative 4 times 1, which is negative 16. (64 minus 16 is 48. Mr. M, can I cancel these 8s? No, you can't. You can't do that because there's a plus or minus here. If this was a multiplication dot instead of addition or subtraction, then you could cancel the 8s. But when there's plus or minus, you can't do that. So we have 8 plus or minus square root of 48. Man, 48 is not a perfect square. Shucks, shoot, darn. I have to reduce this radical. But what perfect square can I divide 48 by? 16. If you didn't remember 16, you could have done 4 and 12. And then remember that 4 also goes into the 12. So you would have had to take the square root of 4 out twice. But it's just faster to know that 48 is 16 times 3. Not something you have to do. It's just something I always taught to my Algebra 1 students, but I identify the stuck thing. That way I know I'm not touching that, but everything else has to be dealt with. And the square root of 16 is liberated. It is a 4, square root 3, all over 8. Before you simplify, what you need to do is split this into 2 fractions. Then reduce your fractions. So 8 over 8 plus or minus 4 root 3 over 8. They're not like terms, so we might as well just leave it as the plus or minus. 8 divided by 8 is 1, plus or minus, and you can divide the top and bottom of this one by 4, and you get root 3 over 2. These 2 solutions are real. What does that tell us about our graph? That I have 2 real solutions. What does it tell me about my graph? How many times? Twice. There we go. Ian says it crosses the x-axis twice. Yes. Because I have 2 real solutions, guaranteed this graph crosses the x-axis exactly 2 times. Even more powerful than that, we know that the axis of symmetry is at x equals 1, and that the 2 solutions are root 3 over 2 away from the axis of symmetry in both directions. These 2 solutions are irrational. Just confirms for us that factoring would not have worked. I would have checked that first and foremost though. 4 times 1 is 4. And there are no 2 numbers that multiply to 4 that add to negative 8. So we would have seen real fast that factoring doesn't work, telling us our answers were either complex or irrational. These were irrational. Questions, comments, concerns on using the quadratic formula? No. Algebra 1, right? No big deal. Yes, ma'am. Before you reduce your fractions, yes. Because here's the thing. I could have done it right here. I could have reduced, right? But what's the only number that I can divide 8, 4, and 8 by? Because you have to reduce all 3 at the same time if you want to leave it like this. The only thing that you could divide all 3 of those by is 4, right? So that would have given you 2 plus or minus root 3 over 2. But you still have to separate it to get your 2 solutions. So you might as well separate first and then simplify your fractions. You're less likely to make a mistake if you do it that way. Now the second one, like I said, bad copy paste job. I accidentally left it as minus 8x. It should have said minus 2x. My apologies. A is still 4, B is negative 2, C is still 1. I actually had to come up with that correction on the fly last period because I didn't catch it before class. I always write my quadratic formula so I don't have to try to keep it in my memory. Because I don't want to have to deal with, was there supposed to be a negative sign there? Did they cancel those negative? I don't want to do any of that. I just want to look at it and plug it in. Negative, my b value, plus or minus root, my b value squared, minus 4ac. All over 2 times 4. So like I said, please trust your math abilities a little bit before you touch a calculator, please. And you notice that I'm using parentheses anytime I substitute. I hope by now you're in that habit. Please do that. You're less likely to make double negative mistakes if you do it that way. Anyway, minus negative 2, negative 2 is positive 2, plus or minus square root of negative 2 times negative 2 is positive 4, and that says negative 4 times 1, which is negative 16. Still over 8. All right. B squared minus 4ac this time is going to get me a negative number. Negative 12. And crud, still not a perfect square. Wait, even worse, it's negative. So we have to split that. We have to reduce this radical. What two numbers do I want to split my negative 12 into? 4 and... Hold on, no, you're trying to give me the result. I just want to split what two numbers multiply to give me negative 12. There we go, negative 4 and positive 3. So take the negative sign with the perfect square. You can't ever leave a negative sign inside a radical, so you might as well take it with the square. I'll identify my stuck object. Square root of 4 is 2, so the square root of negative 4 is 2i. Then there's a root 3. And just like before, you're going to need to write this as two fractions. So split them, please, with a plus or minus in between them before you reduce your fractions. So I have 2 over 8 plus or minus. And remember, standard form for a complex number is a plus or minus bi. The I needs to be to the right of the fraction. That's going to give us 2 root 3 over 8i. In order for it to be standard form, you don't want to leave that I on the top of the fraction. See how I did that? I wouldn't have an answer on the test where the only thing that was wrong is I put the I on top of the fraction. I wouldn't do that because that's just mean. And I'm going to be like, ha, you didn't pick the one that was most correct. Gotcha. I wouldn't ever do that. But just so you know, it's not technically standard form until it's off to the side. Both these fractions reduce the same way. You can divide the top and bottom by 2. It's going to give me 1 over 4 plus or minus root 3 over 4i. I have 2 complex solutions. But I still could tell you where the axis of symmetry is. It's at x equals 1/4. Now here's my question for you. Since I have 2 complex solutions, what does that tell me about my graph? Matt? Does not cross the x-axis. Perfect. On Friday, I believe it was Friday, I talked about this, but there are 4 different ways to describe solutions if they are real. You could say you could call something a solution. You could call it a root. You could call it a 0, or you can call it an x-intercept, as long as the solutions are real. Those 4 things all mean the same thing. But the moment your solutions are complex, you no longer have 4 equivalent statements, because I can't call these x-intercepts. By definition, they're not on the x-axis. I could still say it's a root, I could still say it's a 0, and I could still say they're solutions, but they are not x-intercepts. And technically, again, being very technical here, because they're complex, I should have said z equals. Complex conjugates. 1/4 plus root 3 over 4i, 1/4 minus root 3 over 4i. Complex conjugates. How interesting that here I got 2 real irrational solutions, so my graph crosses x-axis twice, and here, and they were irrational conjugates, and here I got 2 complex conjugate solutions. I wonder what the determining factor was between having real solutions and complex solutions. You have an idea? B squared has to be large enough because you're trying to, what were you trying to ensure happened? There we go. She was trying to say that B squared would need to be large enough to make it so that you don't get a negative number inside the radical. That's actually called the discriminant because it discriminates. If you have a quadratic equation written in standard form, ax squared plus bx plus c equals 0, where very specifically a, b, and c are rational numbers, that means they can't have radicals. And you also can't say a is 0, because if a is 0, it's not the quadratic, it's a straight line. Anyway, if you have ax squared plus bx plus c with pretty answers, or with pretty a, b, and c, the discriminant is going to be the thing underneath the square root bar, b squared minus 4ac. It determines the kinds of solutions you get. It doesn't tell you what the solutions are. It tells you what kinds of solutions you would get. And since discriminant starts with D, a lot of places around the world will use the symbol delta to represent it. It's the symbol delta. It's a Greek letter. It's the Greek letter for D. Delta. No. This is the Greek letter delta. What? How is a letter a word? Did you just ask me how you can spell? This is the Greek letter delta. Yes, the Greek letter delta. Okay. Okay, you ready for this? This is the English letter W. See how I said words? Did you really just ask me how the letter can have a word? Letter W. W. It's literally the word double and then the letter U. W? W, not W. It's W. What is that? What? This is a W. A W. That is the logo for Delta Airlines. Okay. It's a letter. It's also the words double U. W. It's the word double. So that triangle is a letter. It's a Greek letter that has a name. No, it doesn't mean a word. Its name is delta. Is it D or delta? Letter is like a singular letter. This is the Greek. Okay. I think what. Okay, how many letters are in the word W? D-O-U-B-L-E-U. There's actually 7 letters in W. It's a singular letter, but its name has 7 letters. This is a singular Greek letter. Its name has 5 letters. I think that you're confusing a symbol with the word we use for the symbol. This is a symbol. What word do we use to describe this symbol? F, which is spelled E-F-F. What? I've never spelled the sound before. Yes, you have. You've never spelled boom. That's a sound. Or bang. That's a sound. Doesn't matter. He just said he's never spelled a sound before. Okay, well, that's on you. Just because you haven't done it doesn't mean people don't. Nobody? No? Nobody?
If I'm writing if I'm texting you F-U, I'm putting in singular F and then U. I'm not putting E-F-F.
Wait, this is because is it like Spanish where Y, ultra base, stuff like that?
No, it's like every language on the planet you've completely derailed this entire lesson. Every language on the planet that has an alphabet, there is a spelling of every letter in their alphabet. Don't say no unless you know you're correct.
What's the spelling of
A.
C? That's a letter.
Okay. How do you spell B?
B-E-E.
Thank you. It has a spelling. B-E-E. No. No. B-E-E is how you spell the letter B. Q? Q. Or you could spell it this way. But that's a British word for Q. That's a line. Yeah, in a queue, yeah. Yeah. It's good that you know some of those things. Anyway. Our English arts department needs some talking to. Anyway. Yeah, W is a German thing. In German, it's actually W, which literally means, what? No, not W, sorry. Now you can screw me up. W, that's Spanish. In German, it's... crap. Now I can't remember it in German. Now I'm screwed up. Anyway, back to the lesson. The point is, the discriminant, you guys screwed this whole thing up. The discriminant is, it's Camden's fault. The discriminant is a piece of the quadratic formula that could be used to determine what kinds of solutions a quadratic has. If the discriminant gets a positive value, if b squared minus 4ac is a positive number, which is a number that's bigger than 0, then, like you saw on the front, you will get 2 real solutions. But what if that positive number was a perfect square? You see, the one we got on the front was not a perfect square, but let's just say, for the sake of an argument, let's say in here it didn't say 48, let's just say it said 16. Square root of 16 is 4. You could have 8 plus 4 divided by 8. That's a rational number. 8 minus 4 divided by 8. That's a rational number. So if b squared minus 4ac is positive and a perfect square, you do get 2 real solutions. But they're rational. And they're different, which is the word distinct in mathematics. 2 different, real, rational solutions. That was a lot of adjectives. Felt like I was ordering a drink at Starbucks. Well, what if b squared minus 4ac is positive but not a perfect square? Well, that's what happened on that first example. We ended up with a square root in our answer. That means we have 2 real irrational solutions. Now, they're still distinct. Distinct just means they're different numbers. Yes. This one says rational. This one says irrational. The point is, there's 2 solutions. And we've already discussed it. Ian told us if you get 2 real solutions, we know that your graph crosses the x-axis exactly twice. So here's an example graph. It hits the x-axis 2 different times. I could have drawn any number of quadratics that hit the x-axis 2 times, but there's one that hits the x-axis 2 times. Oh man, Camden, you're going to be so upset the first time you see a mathematical symbol that's actually a word instead of a symbol. Because it's coming.
What if there's that triangle
Delta.
with a word after it? Like, is it delta O, delta go, delta boat, or is it like what? Delta boat. What is it? If it's triangle word, what is it? What's the word?
I've never come across that before.
But it's a letter. Letters go with other words. Letters go with other letters.
Are you asking me how to spell Greek words using the word delta? Or the letter delta? Is that what you're asking me?
Where is, like...
You know, there's a lot of things outside of the English language. I encourage you to grab a book every now and then and open it. You might be astounded at what's in this world. It's not an English letter, so we don't use it in our words. But it is a letter.
So you can take 4 Greek letters and put them together
Oh my God. Okay, this lesson's never gonna. You know what? I'm glad. You know, you're not gonna have any time to do your homework, but I'm educating the masses right now. In case there are any other dinglings watching this video on YouTube, I am going to write a word.
Oh, the YouTubers want to see it. The YouTube wants to see. That's not a letter. Whoa, that's a fish. That's a cross. That's a cancer fish. I'm not sure what that one is.
This,
That's a mountain fish.
and this is how I know that this is not AP Pre-Calc, because this is mu alpha theta, which is our Math Honor Society. Yeah, these are the Greek letters mu, alpha, and theta. It spells math in English. M-A-T-H. Mu, alpha, theta.
This is like a frat. Alpha.
It's Greek letters.
Wait, the second one's alpha.
That's alpha. It's lowercase alpha. Mu, alpha, theta. Anyway, I'm finishing this lesson. I don't know about you guys. Okay, b squared minus 4ac. If b squared minus 4ac equals 0, well, the quadratic formula, if you put a 0 right here, look at this. Boop. If you put a 0 right there, the plus or minus doesn't do anything. So how many solutions is that? One real solution. Very interesting. One real solution. But Mr. M, I thought you said all quadratics have two solutions. They do. No, it's one real solution. So what happened to the other one? Oh, it's repeated. It has two solutions. They just happen to be the same number. They're not distinct. So it has one real solution. It's a repeated root, we say. So the question becomes, how is it possible that a quadratic only has one solution? What would that graph look like? It's not a straight line. It's got to be a quadratic.
You just wrap it back and it hits the same spot twice.
What does that mean, hits the same spot twice?
Oh no, it's horizontal.
No, it's a quadratic.
On the same line.
There it is. Thank you, Matt. The vertex is on the x-axis. This quadratic has one real solution. It's repeated because the vertex is on the x-axis, which means that one solution is also the axis of symmetry. You never know when I'm dropping extra credit knowledge bombs on you. Now, I think delta was a bomb for you. If b squared minus 4ac happens to be a negative number, like it was in the second example on the front, then there are no real solutions. No real solutions. But that doesn't mean there's no solutions. There are two complex conjugate solutions. No real solutions implies there are two complex conjugate solutions. Yes?
Does that mean the parabola is just like not on anywhere near the graph? It's just like floating in like an area.
When you say it's just floating in the area, be more descriptive. Tell me what's its relationship with the x-axis if there's no real solutions?
It's under it.
If it's under it, which way does it have to point? So what you're trying to say is it doesn't cross the x-axis. So it could be under it and point down, or it could be above it and point up. Yep. All right. So these next three examples, gee, I wonder why there's three of them. Maybe because there's three possibilities. These next three examples just say to describe the roots. Don't find them. Nobody cares what they actually are. Just describe them. All right, well, I'm going to be finding out what b squared minus 4ac equals, because all of those things up there were all about the discriminant. B squared minus 4ac. Let's see what we get. B is negative 6 minus 4. A is 2. And C is negative 1. Watch out. That's negative 4 times 2 times negative 1. That's the product of two negative numbers. So it's going to be positive 8. This gives me 36 plus 8, which is 44. My discriminant is a real number. Is this a perfect square? No, it is not. So I have two real irrational solutions. And remember, that means they're distinct. That means they're different numbers. What are they? Who cares?
Wait, so if the answer you get is perfect,
If you get a perfect positive square,
then it's two rational.
two real rational solutions. Yep.
And if it's not a perfect square, then it's two irrational.
If it's not a perfect square, you get irrational because you couldn't take the square root of it by hand. Right. Let's do it again. Let's see what we get. 4 squared, negative 4 times negative 1/2 times negative 8. Watch out! That's the product of 3 negative numbers. This result will be negative. Let's see. Negative 4 times negative 1/2 is positive 2, and 2 times negative 8 is negative 16. Oh ho. My discriminant equals 0. No. Come up here where the discriminant equals 0, and you will see that means there is one real repeated solution. That tells me my axis of symmetry is my only solution, and that only solution, the vertex, is on the x-axis. That's what that tells me about the graph. Can I flip the papers over? Awesome. Boop. One more time. What color did I write that in? That one was blue. Let's do this one in purple. He says this be easy. This is the light work, huh? Okay. Watch out. That's the product of 3 negative numbers. It's going to give you a negative result. 4 times 2 is 8, and 8 times 3 is 24, so that's negative 24. This gives me 16 minus 24. My discriminant is negative 8. Because my discriminant is negative, what do I know about my solutions? They are two complex conjugate solutions. So this is no real solutions. That means there are two complex conjugate solutions, and technically, I mean, if you want to get really technical about it, which I would never do to you, but there are two complex conjugate irrational solutions because 8 is not a perfect square. But the most important part is that they're complex. I had someone ask me in first period, what happens if it's negative but a perfect square? Well, they're still complex. They're just rational complex numbers. It's not a big deal. But they're still two complex numbers. Negative means you're trying to take the square root of a negative number in your quadratic formula, which gives you complex. There you go. So there'll be an I. Yep. How do we feel about using the discriminant to determine what kinds of solutions we have, meaning how our x-axis and our quadratic interact with one another? Cool with those ideas? Because you know that my extra credit questions are always understanding style questions, usually understanding style questions. Like not just difficult mathematics, but usually if you understood that concept, then the extra credit was easy. Then we'll move on to the ones that are actually fun. It says, hey, here you got a quadratic and you don't know what the y-intercept is. Remember, if it's the constant at the end of the standard form, it's the y-intercept. It says you don't know the y-intercept. Find the values of C that would make this graph have two real distinct solutions. See, I said distinct instead of different. It means the same thing. So if you have two real distinct solutions, what does that tell you about your discriminant? Look back at your table, guys. If you have two real distinct solutions, what does it tell you about your discriminant? It's greater than 0. My discriminant is greater than 0. Awesome. I know that b squared minus 4ac must be a positive number for this to be a true statement. So I've got 4 squared minus 4 times my a value is negative 2, and I don't know c. I have to, no, we're not finding magic c. We're figuring out what value of c would make it so we always would get two real solutions. And they need to be distinct. So this is going to give me 16 plus 8c is greater than 0. So you just subtract 16 from both sides and then divide by 8. And what you find out is as long as the constant at the end is greater than -2, this quadratic will touch the x-axis 2 times. If you pick -2 or smaller, it will not touch the x-axis 2 times. That's what this says. What's that? Because I didn't feel like writing b squared minus 4ac. That was over here I wrote it. This is the symbol delta. In fact, you've used the symbol delta before in slope. Change in y over change in x, correct? Okay, yeah. Change in y over change in x. Delta is also the symbol that mathematicians use for change. This one says you don't know the b value, but you do know you want one real solution and only one real solution. So what does that tell you about your discriminant? Has to equal 0 this time. This time your discriminant must equal 0. Oh, my b value is unknown. It's b. A is 9 and c is 1. This tells me b squared minus 36 is 0. Add 36 to both sides. Now what? Square root. What do we have to remember to do when we cancel that square with that square root? Plus or minus. Good. And the square root of 36 is 6. So there we have it. Our quadratic could have a positive 6x in the middle or a negative 6x in the middle. Either one of those values for b would guarantee that this thing has one real solution. So either one of these two numbers right there would guarantee that our x-axis sits, no, excuse me, our vertex sits on the x-axis. Yes?
Add 36 to the other side.
Yes.
Just look at it, it would be like 6 squared equals 36.
But then you might forget that it's plus or minus. And that's why I'm doing it that way. You also could have factored it. This is the difference of two squares. So you could have called it b plus 6, b minus 6. But anyway, I hold up this nerd sign even though you all stopped paying attention the moment he asked his question.